lecture number 15. Now next we proceed with the important theory, that is the crystal field theory. See, I have not written the limitations of the valence bond theory over here. Okay, तो valence bond theory के जो limitations है, you can read it by your own, तो उसमें there is no problem, I think so. So we directly proceed with the crystal field theory, and I explain because इसमें ना the fourth point is very important that you need to understand. Okay, now let us start with the very first. In the complex, the central metal atom or ion, it is surrounded by the various atoms or the group of atoms which is called as a ligand. मतलब क्या, as you know that it is very simple. जो central metal atom है, it may be a even ion, that is a transition metal. वो transition metal surrounded by ligands, and ligands क्या करेंगे, they will donate the electron to the metal atom or the ion because it has got the vacant orbitals. That is the first point. Okay, now the second point. The ligands, they are either negatively charged, they may be neutral. जो neutral ligands है उस पे it will have a lone pair of electrons. Now neutral ligands के examples क्या है, water है, ammonia है. तो as you know they have got lone pair of electrons on them. And in the neutral ligands, the most electronegative atom, it is pointing towards the central metal ion. मतलब क्या, neutral ligands में, that is I am speaking about the second point. Neutral ligands में, for example water है, water is a neutral ligand, तो oxygen will be pointing towards the metal. और ammonia है, तो electronegative ज़्यादा कौन है, nitrogen, so that would be pointing towards the metal. That is the second point. Okay, the next third point. Both the metal ion and the ligands, they act as the point charges. So the bond or the interaction, the force of attraction which is present between the metal and the ligands, that is electrostatic force of attraction. It is not a covalent bond. It is not because of overlapping. ये valence bond theory नहीं है. It is a crystal field theory. Okay, that is the third point. Now we proceed with the next point. See, listen, try to imagine what I say. Try to imagine, I said, fourth point. अभी ये ligand है, okay, ये ligand है. Now this ligand approaches the metal. Ligand approaches the metal. The electrons of the central metal atom, इसके जो electrons है, and those of the ligands, इसके electrons, they will repel each other. So that is the sign, they will repel each other. Now this repulsive force will destroy the degeneracy of the d orbital and split into two groups. They are called as T2G and Eg. For example, now see, this is the d orbital. I have taken a rough example because everything depends on the geometry. So for you to understand, see what has happened here. This is a d orbital and this d orbital splits into 3 and 2. This is T2G and Eg. Okay, this is what I mean. This is called as crystal field splitting. The crystal field splitting, it depends on the geometry of the complex. Very important. This is because the d orbitals, they differ in their orientations. आपको d orbital का geometry मालूम है, तो they differ in their orientations. Fine? Okay, this point is very important. Pay attention. Fourth point, this. The d orbital, next when I'll explain the geometry, I'll try to draw the diagram and then you will be able to understand. But try to understand what I say here. The d orbital lying in the direction of the ligand. The d orbital lying in the direction of the ligand, they are affected to a greater extent. जो उसके direction में है, they will be affected to a greater extent, while those which are lying in between the ligands are less affected. जो उसके direction में है वो ज़्यादा affect होंगे, वो जो बीच में है they would be less affected, and this is due to the repulsion, the orbitals along the axis of ligand, they will acquire higher energy because वो ज़्यादा affected है, they will acquire higher energy and the other will acquire a less energy due to the repulsion. Repulsion यहाँ पे less होगा, so there is a less repulsion, वो lower जाएंगे. Therefore, on the approach of ligands, the two sets of the d orbitals of central metal atom having the different energies are formed, and the difference in the energy between the set, it is called as the crystal field splitting energy. Crystal field splitting energy, that is represented by delta. Okay, and this is often, it is having a unit that is of 10 dq. Delta is equal to 10 dq. Again, the exact amount depends upon the geometry of the complex. That is regarding the fourth point, which is very important. Next point, the electrons of the metal atom, they occupy the splitted d orbitals strictly in according to Hund's rule. I think every one of you know what is Hund's rule. Need not explain here. 11th standard. They'll obey the Hund's rule. The electrons will first occupy those orbitals which suffer less repulsion. That is, the orbitals which have their lobes far away from the direction of the ligands. Next, the theory does not account any overlapping between the orbitals of the central metal atom and those of the ligands. As I said, it is a purely electrostatic force of interaction. वो point charges है, so it is electrostatic. It is not a covalent bond. So it doesn't have a covalent character. That does it mean. Next, the stability of the complex can quantitatively be known by the magnitude of the CFSE. CFSE मतलब क्या? Crystal field stabilization energy. I repeat, crystal field stabilization energy. The magnitude of CFSE, it depends on the nature of the ligands, it depends on the number of the ligands, it also depends on the geometry of the complex. Okay, now the crystal field stabilization energy is actually the gain in energy which is achieved by the preferential filling up of the orbitals of the electrons, and that will be less than 0. अगर 0 है, it signifies that the complex is not stable. So that is all about the crystal field splitting. Crystal field splitting का मतलब क्या? The splitting of the 5 degenerate d orbitals into two different sets, T2g and Eg, having different energies in the presence of a ligand. That is called as a crystal field splitting. That depends upon the geometry of the complex. Next, what do I mean by crystal field stabilization energy? This is the change in energy achieved by the preferential, वो जो हमने बताया ना, that will be equal less than 0. Higher the negative value, more is the stability of the complex. Okay, that's all for today.